When we talk about skilling, most of the time we seem to be focusing on skilling of technicians, machine operators, and in general about vocational training of a lower level. My talk is about skilling of engineers. Today is the time when everybody is talking about Make in India as well as defense indigenization. I would say defense indigenization is a subset of Make in India, and therefore I will focus primarily on Make in India and the opportunities that it opens up for all of us. When people say Make in India, many people misunderstand this as just manufacturing in India, whereas I believe that it should include design in India, innovate in India, manufacture in India, and consume in India. Let's look at all the appliances that we use on a day-to-day basis in our daily lives. We use microwave ovens, we use LCD TVs, we use refrigerators, and various other home appliances. And what are the brands you see in the shops today? They are Korean brands, they are Taiwanese brands, Japanese, and Chinese. So when we talk about manufacturing, it's not manufacture of these TVs that we should be discussing. We should be talking about Indian brands that are designed in India and manufactured in India using Indian manpower. So why do we need to import these appliances? Many people think that we are manufacturing these under license in India, but I would say, why do we need to manufacture under license at all? Why can't we design and manufacture ourselves of Indian designs? On the other extreme of the spectrum, we have defense equipment, aerospace equipment that are used on our fighter aircraft, transport aircraft, and even ground test equipment, which are all completely imported from abroad. Even in the so-called indigenous design LCA and the ALH, which are certainly prestigious projects, we seem to have a high content of imported equipment. If you want to design and manufacture in India, you need a factory, which we certainly have in plenty. We need modern machineries, which again we have in plenty. Technicians, we have plenty of them, operators, because we have seen the automobile sector, how they have created the ecosystem, and we are even exporting automobiles from India. But then, the missing link happens to be the design engineers, whether it is automotive sector or the aerospace sector or the defense sector. The missing link is the design capability. Let's look at what our quality of engineers are that are coming out of the colleges now. You have engineers, 1.5 million of them coming out of our engineering colleges every year. And the industries say that hardly 4 to 7% of these engineers are capable of being employed into the manufacturing sector. They say there are no analytical skills among these engineers. The industrialists say they possess no practical skills. Why? I would say it's because the engineering colleges do not have the infrastructure and the environment to imbibe these skills into the engineering graduates. I would say now that instead of just churning out engineers, they need to be empowered to be capable of designing products, learning how to repair and maintain those products. So let's now look at how we can build this design capability into our engineers. Let's look at what needs to be done to create practical engineers out of the graduates that are coming out. They need to be oriented towards practical engineering, which means that they need to train on live projects and in turn in industrial environment. They need to get an insight into products, whether they are LCD TVs or refrigerators or microwave ovens. They need to get into the act of dissecting a product, studying those products, how the plastic molds are made, how the plastic components are designed, how the PCBs are designed, how the circuits have been designed, and learned in the process, and then perhaps even learn to repair them. In that process, they will educate themselves about how the circuits work, how the products are put together, how they are disassembled, how they are assembled. In this process, they would also get ideas about innovating further of the circuits, the PCBs, the machineries, and the production process. I believe this is a very strong learning process. Let's look at what I've done over the last 35 years in my company called Radl. We started developing musical instruments, electronic musical instruments for the Indian musicians. There were no electronic tanpuras or electronic tablas when I started developing these. I invented these for use by Indian musicians because I knew that they were handicapped by the lack of proper support for their practice and for their travel abroad. That's how I created the need for these products. I designed the products and in the process trained many of the engineers on the art of designing electronic circuits, electronic PCBs, and then assembling them and then putting them into plastic molded cabinets. All these activities are done within the four walls of our organization. This is how we developed an electronic tabla, the electronic tala instrument, electronic veena, and the engineers were trained on developing software that goes into these products. The engineers were also trained on designing the printed circuit boards on which these electronic components are mounted, and then the plastic housings which need to be acoustically designed, aesthetically designed, and then capable of being designed to hold these various components and the parts such that it is easy to manufacture as well as easy to repair and maintain. This is how we went on to develop a team that learned the art of designing electronic products. Once we did this, we decided that we could use the same engineers to design not only musical instruments but also high-tech avionics products for use in Indian aircraft, fighters, as well as naval ships. We ended up creating a team of engineers that designed and developed the distributor that goes onto a Jaguar aircraft, then a bomb release equipment, then an engine starting sequence controller, and various associated ground test equipment which were 100% indigenously designed, manufactured and supplied to HAL, the Indian Air Force, the Indian Navy, and various other organizations. This is how we believe that we need to create engineers who can participate in this whole Make in India. Let's now look at what is the common thread that runs through the entire spectrum of creating engineers that meet the needs of aerospace and defense on the one extreme and electronic musical instruments or consumer products on the other extreme. The common thread is that we have developed innovative solutions. We have built in a very stringent quality system where the products that are designed have proven themselves to be extremely reliable, extremely efficient, extremely compact as required by the aerospace and defense. They are very rugged and they are also very highly miniaturized. This is what we have demonstrated over a 35 years track record of innovation and indigenous development in spite of being an MSME. Our engineers have got the exposure to a complete product life cycle, right from design, that is I would say conceptualization, design, and also the criticality as associated with aerospace and defense. With this 35-year-old track record of churning out engineers with the capability to design, manufacture and generate these products, we said we can as well create a separate institution, a vertical, and that's how the idea of Drona School of Engineering Practice was born. We have over the years trained more than 150 such engineers who are capable of designing products in the mechanical sector, in the avionics sector, in the consumer electronics sector, PCB design, software design, etc. And they have all been absorbed in very reputed MNCs and larger organizations. We now believe that we look forward to training and mentoring such engineers in much larger numbers, and that's what's going to happen at Drona, the School of Engineering Practice.